As host, I give you power to speak. All right.
Thank you. Yeah, I don't know if you don't mind, I might keep it a bit shorter today, and maybe we can dive into the open theory questions next week, because yeah, I'll see how much I'll have to cover that talk, but it's also already 1.5 hours in. But yeah, maybe I'll just give a brief overview of this wiring diagram, and then how I've kind of used it to think a bit about the compositionality project and the open theory questions. But then, yeah, kind of talking in more depth about the open questions, I think is like a whole several topics on their own probably. So, um, but if you want to talk about any of them, we can. Um,
This is
so
our own version of the Feldman-Vinessen diagram. It's almost
That's exactly what
exactly.
I said. That's why I thought that she figured out the cortical circuit of the brain.
Well, it's not that. This is the region product connectivity. No,
Right.
it's remarkably similar.
Yeah.
yeah, I tried to make a hierarchy, but it was definitely a heterarchy. Um,
Right. Well, there is no hierarchy here, right? I mean, it's well, maybe there is.
yeah, yeah, I tried to keep it kind of mostly flowing upward, but there are definitely some kind of downward arrows, and there should probably be more that I didn't put in because I didn't want to add more downward arrows. Um, and yeah, this is a really kind of high level picture of capabilities we want Monty to have eventually. So it's yeah, basically thinking about okay, if we have a system that has all the intelligence that the human neocortex possesses, all the capabilities that our cortex has, all the things we can do, what would we need? What are all these capabilities? And it's in no way claiming to be complete. I kind of try to keep it at a high level. There are definitely like a lot of details to each of these, a lot of smaller prerequisites for each of these, but these are more kind of higher level capabilities and not about what needs to be implemented to get these capabilities. Um, and I just kind of made an overview for myself because I wanted to have a high level view of where we're at, where are the things we're still unsure about, where are the things that we have ideas on, but we need to test them, where are the areas that we already have validated our ideas, and Monty is already capable of these things. And so that's kind of the color code here. So green is implemented, blue is it's scoped or we have an idea for it, and red is unclear. We don't really have a clear theoretical answer for it. And then green and blue have some shades to them. Some of them are like less completely realized. Like for example, performing efficient inference can still be improved further. Uh, Recognizing objects and their poses under all conditions. We can do some conditions, but not all. So it has some lighter shades in some cases. And then I kind of did some dash dots around some where it's nice to have, which is maybe a bit subjective, but kind of like to have a bit of a priority here of things that maybe aren't as crucial for these key capabilities, but would still help um, in the end. And so there are a few boxes that have a larger font, and those are kind of the big, I don't know, five or so that everything ties into, which is let me start. Maybe I'll
Yeah, if you're
start.
gonna, might make a suggestion. I didn't catch the font size. Maybe you can make those rectangular or something, so make them pop out. So I know that I didn't realize there were five things that were like top line things.
Well, it's a bit subjective that it's just these five. I mean, that's why I didn't distinguish them. All of them are capabilities that are all important. It's just, I mean, maybe it turns out attention should be one of them, for example, or
All right, all right.
it
Well,
might change that.
anyway, for the font size, I didn't catch that. So if you meant to
Yeah,
convey something, it wasn't conveyed.
I
So
guess they're the ones that are getting the most arrows to them.
yeah, right. I
Or
can
now
okay,
you can
maybe
recognize it now that she pointed it out.
right. Well, I
Okay, so we have Modeling and recognizing compositional object, which we live in a compositional world. If we want to be efficient in any way, we don't want to learn monolithic objects of like our entire world around us. We want to be able to reuse models of things in different contexts. And that then ties into both efficient learning and performing efficient inference, which are two pretty broad capabilities. Hence, you can see there are a lot of arrows that feed into them. You can improve efficiency of learning and efficiency of inference in a variety of ways. And this is not necessarily, yeah, this is more like capabilities that contribute to that. And some of them we already implemented, like voting or saccading to salient locations. We're using sparse models, and some of them we haven't. Another one is the big one, like behavior of the system wise, like accuracy and wise, which is recognizing objects and their poses under all conditions. And so we have several conditions that we can already do, like sampling new points and paths on an object. Like we can learn an object moving one way over the object and then infer it moving a totally different path, sampling different points on that object. Recognizing object in novel orientation and location in the world. We can do that. Showed that both in the DMC paper. With sensor noise, we can do that. And then there are several that we have some ideas, like object can pose when the object is deformed. Hoji just presented the 2D model, which helps with a lot of deformations. There's still some open questions around these volumetric deformations, like if a balloon is inflating, for example, which changes the surface of the object. One that we haven't really figured out is scale, although, yeah, hopefully it won't be too tricky one. Novel feature and morphology combinations, and yeah, various other things to tie into it. I don't think I should go over every item in here. I'm just trying to give a high-level overview if someone wants to dive in there and then kind of go into how I use this afterwards. So this ability all ties into learning without supervision as well. So basically, not needing to tell the system the name of every object and child object and its orientation, but the system can infer objects and child objects and then learn new arrangements of them on its own. Then the really holy grail capability is manipulating the world to achieve goals. That's the really big one where we have the most open theory questions around it. I have like a big question mark here because there are probably several other items that I don't have on this map even right now. One of the big prerequisites that we figured out early on and then spent more time on is recognizing object behaviors under all conditions. So recognizing them in any location, orientation, and scale, inferring the speed, and modeling object behaviors, which in turn have different prerequisites. And then I have this kind of side bubble here, which is operating in the real world. And you might notice that most of these are kind of dashed ones because they don't seem as crucial. Like nothing depends on this one right like upstream right now. So it's not really the main focus for us at the moment. But here some of the things go in, like estimating depth based on parallax instead of having like a ground truth depth sensor. The general purpose sensor modules that Niels mentioned earlier that can learn from any modality and some other stuff. So yeah, I think to me it was just kind of useful to clarify what is actually dependent on what and how does this big picture look in terms of colors, what's still missing. And then one thing I did with that was extract out everything that ties into modeling and recognizing compositional objects. So kind of this subtree that's related to that, and also clarifying, okay, what are the downstream capabilities that we want to get with that? And the big ones there are being able to do inference and learning more efficiently. That's really what compositional objects give us. Another one is it's required for associating behavior with morphology, because we were at least planning to do that using hierarchical connections. Yeah, so
I don't know if you,
that's
I don't know if you represented in here, but when I think about compositionality, we spend all this time talking about things like, logos on mugs, but to me, it's largely about the dynamic nature of the world, where, use my intersection example, like right now, where are things relative to other things? Where are the people? Where are the cars? Where are the bikes? Um, those are all compositional structures that are always dynamic, but they have to be represented in the same way that we represent other things. I don't know if you included that in this picture or not.
Yeah, I'd say
But
that's part of being able to learn efficiently. Like you have a temporary scene and you can quickly learn it without having to
okay,
attend to every detail of
it's
every object.
that's part of it. I mean, also part of it is that it's not just efficiently, but it's very dynamic. So moment to moment, I have to relearn the whole thing. And, today it's different than yesterday. And so it's not just if I just say learn efficiently, like, oh, what's the quickest way to learn the mug logo on the mug? But to me, it's more like when we're interacting with the world, so much of what we do is there's this temporary compositional structures. So maybe it's the temporary aspect of it. It's like when I say it's dynamic, it's like it's constantly changing as we move around the world. The world is moving, and things are moving in the world. Um, so it's
Yes,
more than just it's just a broader thinking of what it means to be compositional structure.
yes, I have learned temporary models and generally also like consolidate memories and forget again. Um, but I don't have that dependent on modeling compositional objects because I feel like you can learn temporary models quickly without them being compositional. It would just be less efficient if they're not compositional.
Well, yeah. Well, it would be impossible, really. I mean, it's less efficient to the point of impossibility. I
Yeah.
mean, uh,
Yeah.
again, just imagine you look and all of a sudden you see, though, that kid's here and the ball's there, and someone just opened the door over here. These are all sort of this is all a big compositional structure that's being dynamically changing. It doesn't suggest any of these bubbles are wrong. I just wanted to emphasize the fact that when I think about what we do, so much of the overall goal of manipulating the world is not manipulating, just sort of things in your kitchen. It's more like you're interacting with things in the world that are moving independently of you, and modeling those.
Or yeah, like almost by definition, things we can interact with are dynamic and change from moment to moment. If they're
Right.
not, then
I mean, but like
the
the
position of
state,
a
this
handle on a mug cannot really be changed.
right. Well, the
And so,
stapler's got is the stapler's compositional and it moves and so on. And that's important. But again, I think it's really different to say like, being at that intersection, you're trying to decide if you can cross the street, and you have to see where the cars are right this moment and build a quick model of everything you just in your point of view. And that model is going to be only last for a few seconds. It's valid. Its usefulness is only last for seconds. So anyway, it's not saying anything on this picture is wrong because I like this picture a lot. I just have a broader view of what it means to be compositional objects.
Yeah. And I mean, yeah, learning efficiently and doing inference efficiently, those are no small things. They're prerequisites for like pretty
Right,
much any actual task.
right.
Like you said, to be able to manipulate the world, we need to be able to learn and do inference very efficiently. Um, to recognize object behaviors and to learn them, we need to do those very efficiently, as we talked
Efficiently,
about.
like is like in
And
one shot. It's like I have to be able
yeah,
to do this instantaneously. One view of the car, and I know there's a car at that intersection at this position.
right.
Yeah, so sometimes we think about efficiently, like, oh, I can run this on 30 seconds versus 45 seconds on this GPU cluster, but
Yeah.
but we're not
So
talking
this
like
is
that.
yeah, this is not just, oh yeah, it'll run a bit faster, or like if we just bought some GPUs, then we would get the same thing. This is like really core algorithmic efficiency that's necessary for any reasonable real world
What
application.
is that? What's the bow tie icon represent? I don't know what that means. But
It just means that there are a lot of other arrows that would go in there that I'm not showing here.
oh, is that a known
It
thing?
stands for magnitude, isn't it? Like it
I
contributes
copied
to
that
that thing
from,
increasing.
yeah, I copied it
The,
from Tristan's use of it in the future reality trees.
Okay, got it.
Yeah, right. It means, yeah, these increase inference efficiency, but it's not that if we have these three, then it's efficient, it's all done kind of thing. Um, and so, yeah, just really high level thing. Orange parts are the capabilities we'd want to demonstrate, and these are generally requirements for those. And then since these are really just capabilities, so if you look at this yourself, you can read it as Monty is able to, and then fill in whatever's written in here. And then if that statement is true, that card would turn green. Um, but then we're able to say Monty's able to deal with incomplete models. Monty's able to learn 2D models. Uh, Various things need to happen. So then that can help us kind of plan out these things that need to happen. So for example, I went through that with the compositional modeling work and all the items we still have on our roadmap to do on that. And yeah, we can go through that in more detail in a technical research meeting. And most of them you all are aware of already, anyways, or whoever is working on that part. I guess, yeah, this one Jose just presented demonstrate recognition of logos on various shapes. So, uh, yeah, so we can mark that one green very soon. And then the second thing I use this for is just to get an awareness of like what capabilities do we eventually want, but we still don't know how to get them. So all the red parts on here, even though some of the blue parts are still less certain as well, um, since we haven't tried them yet, so it might turn out this doesn't work. It will turn red again. But just looking at the red parts, I moved them over to this board and grouped them by general topics, since I think that makes it a bit easier to discuss them in context with each other. So there's the general topic of attention, segmentation, and input sharing. There's unsupervised learning, which is kind of a theme that we've had pretty much since the beginning of Monty, and that keeps coming back, especially also now in the compositional modeling work. Goals and actions, this kind of really big open question here. And then smaller ones, scale and deformations, and generally model representations. There are several questions around how we might represent things like symmetry or patterns, textures, sets, where an object ends, incomplete models, abstract models, and so on. And then, yeah, I put a couple of notes under each of them on what I think we thought about these topics so far, ideas we had around those so far, or just generally what the problem is there, if someone wants to read or add things to it. Um, but yeah, I don't know. You want to go through these now,
Do you
or
want people to edit this?
you can, yeah.
I mean, because as you know, when I saw your first diagram, I took out all these red things and put them in a Word document, and I was working on it. Um, but I didn't think about editing this document. So I
Yeah,
don't know.
if I mean if you're worried about editing it, you can just make a copy of it and make edits, or if you want to just add comments to what I added here.
Well, I was just using it as a base for doing some other writing, so I don't
Yeah,
need to edit it. I wasn't going to edit it, but you said if I wanted to edit it, so I don't know if you wanted people to do so. Otherwise, it's easier for me not to.
yeah, you
Um,
don't have to.
okay.
Yeah, it's really more. I feel like for me it was a useful exercise to kind of finally put all the pieces on the board and see where we are on them, and especially with the open theory questions. Like it felt like if we look taking the island of Monty from the Legend of Monty as a as an analogy. For a long time, it felt like, okay, there was always some fog over the island, and it was like, well, we don't really know what's in that fog. There might be a lot of other looming questions. But now it feels like we see the whole island now. Um, we haven't really figured out how to settle all the parts of the island yet, but at least we know kind of where the outline of the island is, and um, yeah,
We
kind
know
of
the unknowns or better. Yeah.
yeah, that's how it feels like at least. I mean, who knows? Maybe there's something that we haven't thought about or I forgot here, and if you notice something, definitely bring it up. But yeah, that's at least all the unknowns that I could think of.
No,
Yeah,
I think it was
that's
great.
really useful.
It was very useful. And I think just seeing that there's an end to it is quite motivational because I think we can solve all these things. It's just a matter
Yeah,
of turning the
yeah, and
crank.
I didn't want it to come across the opposite way as like, oh wow, this is very overwhelming and this much. Yeah, to me,
I
yeah,
was
has this
it's the
effect.
opposite.
Okay,
I was
yeah,
the amount of blues and greens is greater than the number of reds, which is very encouraging. Because
yeah,
when I started work on this many years ago, it was all red. There wasn't any blues or
Yeah.
greens. So, and we didn't know what the reds were. We didn't even know what to put down. So just putting
Yeah,
a li-
and
just putting.
I think also we shouldn't feel demotivated by how long it can sometimes take to turn something green, particularly at this stage where we've been improving the code base a lot and spending a lot of time on actually making it easier for future changes. Um, because yeah, I think that's part of a lot of what we've been doing the last kind of half year to year is sort
yeah,
of laying the
Yeah.
groundwork for making changes faster.
Well, moving things from blue to green is a lot of work and be very challenging. But I think it's something you can sort of say, oh, this is the task. This we have to solve this. Well, the red stuff is so much of us like we didn't even know what the hell it was. So and then sometimes you had no idea how to solve some of these problems. So to me, I always felt like, oh my God, the red stuff is the scary part. The blue stuff and the smart people can do the blue to can do the blue to green somehow. They'll figure it out. But there's a question of can you actually figure out what the red stuff is? And at this point,
yeah.
I
Right.
have no doubt about it. Because we've made so much progress that it's clear we have the basic constructs for solving all these problems. So
When you were working on this, Vivian, were there any like kind of surprising connections or things where you noticed like, oh, I didn't realize we need that before we can do this, or yeah.
Yeah, various. I mean, I definitely reordered the stuff many times, and I guess I was at some point surprised that compositional objects ended up so far down here.
Okay, I was going to
Um,
ask you about that because that seemed kind of counterintuitive to me that like it's like you need to recognize an object in order to recognize a compositional object, but I guess yeah.
yeah, I guess yeah, there should be some kind of backwards errors, and it's a bit circular that yeah, you need to recognize objects, and you need to be able to learn without supervision to a degree as well to do compositional modeling. But that's why like these big ones are quite gradual things, and a lot of things contribute to them, and partial ability to do this helps us do some of the other things. So yeah, this top to bottom organization is not
can I
always. So yeah, I think we have enough topic for the next months of brainstorming. If
we're
anyone
gonna get this all
ever
done?
doesn't know what to think about, here are some starting points. If we ever don't know
I
what to talk about, we can
my
just
stretch goal is
come
to move
here.
every one of those red boxes to what was it, green or blue? Blue.
Blue.
That's by
Yeah,
the end of the year. By the end of the
yeah,
year,
stretch goal for
I
the
don't want
year.
any no red boxes. December
That
31st.
that would be nice.
Yeah, it might be. It's a stretch
I
goal. It
mean,
might.
we are looking for kind of simple solutions that cover like several of these problems, ideally. So
Right,
we don't want to
right,
find point solutions for each of these problems. So hopefully that's something
right,
doable if we just think of the right things, the right
right.
mechanisms.
And that's happened many times in the past, so we know that can happen. We've solved
Yeah,
multiple problems with a single idea. Oh yeah, this is the way to do it.
yeah. And so
I'm
yeah, maybe having
optimistic.
them all in one place might help also to see relationships
Right.
between them.
Right. That's why I was so excited your diagram. I wrote down all those red boxes and put them in a Word document and said, okay, this is it. Yeah, figure this out.
Have you figured it out yet?
No, a stretch goal. I said the end of the year, it's a stretch goal. I mean, I don't know. I don't want to hold me against me, but it takes another, 6 months or
Yeah.
something. I don't know. It's a stretch goal.
Okay, so
This is not a 10-year goal. This is like, we're gonna do this soon here. We're getting really close.